Hi students, let's learn about congruent triangles. There are four important rules of congruent triangles, means we can prove two triangles to be congruent by four rules. Those four rules are very important. I'll discuss with you one by one. First of all, congruent triangles means two triangles having same shape and same size. Same shape means they have all angles equal. It means corresponding angles are equal. Corresponding angles equal. That means same shape. Same size means they have corresponding sides also equal. Mean to say, if I grab one triangle and merge on the second triangle, it will fully merge on the triangle because they have same shape, same angles, and same sides, same size also. So in simple words, congruent triangle means same shape, all angles same correspondingly, and same size, all sides correspondingly are same. Now there are four rules we need to learn about congruent triangles. Now this triangle, suppose I call this triangle as A, B, C, and this triangle as P, Q, R. Now first rule is called as triple S rule. S criteria or rule. By this rule, corresponding sides of one triangle, if equal in size to the corresponding sides of other triangle, those triangles are congruent, they have same size, same shape. It means if AB is equal to PQ, then say BC is equal to QR, then third side AC must be equal to PR. So if three sides are equal in corresponding way, means if AB is equal to PQ, then AB don't need to be equal to QR or PR. So in this way, if three sides correspondingly equal to three sides of other triangle, two triangles are called as congruent triangle. So triangle ABC and triangle PQR are congruent. We can write like this: triangle ABC, triangle PQR are congruent. That's a symbol. Second rule, rule number two. Rule number two is SAS, side angle side rule. This is rule number two. So this one was the first rule, triple S. Second rule, SAS, side angle side is second rule. S stands for side, A stands for angle. So that means two sides of one triangle. Suppose I call this a triangle as ABC and this triangle as PQR. Two sides are equal. Suppose I assume this AB side is equal to this PQ and this AC side is equal to PR. Now you can look the pattern now, side, angle, side. So this angle is inclusive. This angle is between the equal sides. So this angle which is equal should be between the equal sides. So mean to say, now in our case, if we take AB equal to PQ, PR equal to AC, that means included angle. The angle which is included between equal sides, that must be equal. So means angle BAC, this angle should be equal to angle QPR. If angle, we prove ABC, if we prove ABC is equal to PQR, because this angle is not included between equal sides, then we can't apply this rule. So it is very important to understand, if two sides are equal, we should take the inclusive angle between two equal sides. So these triangles are again congruent. So these triangles are congruent by SAS criterion or rule. Number 3. Rule number 3 is called as ASA or AAS or sometime SAA, doesn't matter. So it means two angles, one side. So this rule states that if I take this as ABC, triangle ABC, and this triangle as PQR, this rule states that corresponding two angles and a side equal means from one triangle, two sides, two angles are equal to two angles in the other triangle, and one corresponding side. Doesn't matter it is between equal angles or not, it doesn't matter because this pattern is not rigid. ASA, AAS, SAA. So that means we need two angles. We don't mind if the side is not between the equal angles. I explain you here. If I assume that this angle is equal to this angle, and suppose this angle is equal to this angle, suppose, then we need a side. Doesn't matter, we don't take the side AC or PR. We can take it also, but we can take other sides equal also, this BC and QR. So it doesn't matter, the side should be between the equal angle. It doesn't matter, the side should be between the equal angle. It can be any side. So it's a bit different from SAS. In SAS rule, the angle which we take equal should be between equal sides. But here it doesn't matter. We can take any side. So we can take BC equal to QR. We can prove BA is equal to PQ, whatever. So the rule states that if two angles of one triangle are equal to two angles of another triangle, and one side of one triangle also equal to one side of the second triangle, they are congruent by ASA or AS rule. Number 4. This is called as RHS rule. RHS rule means right angle. R stands for right angle, H stands for hypotenuse, right angle 90 degrees, hypotenuse, and one of the side, S stands for side. So that means because it's 90 degree right angle, it means this rule only applies when we have two triangles with 90 degree. When we have right angle triangles, in this case here, these two triangles are right angle triangle ABC and PQR. So when they have right angle, we don't need to prove that right angles are equal. Obviously they are same value, same magnitude. We need to focus two things only. One is hypotenuse. If they have equal hypotenuse and one of the side equal, it's done. So we need to give two reasons only to prove them to be congruent. Okay, first of all, the longest side, hypotenuse, is always opposite to the right angle. We need to prove that AB is equal to PQ. Means this length is equal to this length, this side equal to this one. So both triangles have equal sides or equal hypotenuse or hypotenuse of equal length. And then the rest of two sides can be any. I can prove that this side is equal to this one, or I can prove this side is equal to this one. It doesn't matter, any. So one, we need to show that they have equal hypotenuse. Second, we need to show that they have equal side, one pair of equal side, either the vertical side or the horizontal. That's it. So I'm assuming here AC is equal to PR. So that means these two triangles are congruent by RHS. Okay, I repeat in short way now. RHS rule means if three sides of one triangle are equal to corresponding three sides of other, they are called as SSS. Second rule, if two sides of one triangle are equal to two sides of other triangle and the included angle, the angle between the equal sides also equal, they are called as congruent by SAS rule, side angle side rule. Rule number 3 is angle side angle or angle side. In this case, if two angles are equal and one of the side also equal, that side could be between equal angles or out of equal angles. If equal to one side, one pair of side equal and two pair of angles equal, we call this as angle side angle criteria. Right angle hypotenuse side Rhs rule applies to right angle triangles. We need to prove only two things only, that they have equal hypotenuse and one of pair of other sides also equal. In this case I took vertical sides are equal. So these are the 4 golden rules for proving congruent triangles. If you understand, we can do one exam question based upon congruency of triangles. Let's start doing this question. Here, diagram not accurately drawn. Triangle ABC is an equilateral triangle. If it is an equilateral triangle, that means side AB, side AC, side BC, all sides are equal. And each angle of 60 degrees also. So this angle is 60 degrees. This angle is 60 degrees because it's an equilateral triangle. So this angle is also 60 degrees. Now D lies on BC and AD is perpendicular to BC. D is a point on BC and AD is perpendicular. Perpendicular means this angle is 90, that angle is 90. We don't know D is in the midway of BC, is a midpoint or not, we don't know. So A part, we just need to prove that triangle ADC, green color, triangle ADC, I shade it with here, triangle ADC, this triangle, prove that this triangle is congruent to triangle ADB. So triangle on the left is congruent to triangle on the right. So when I see the right angle in these two triangles, it clicks in my mind that I should go with the 4th rule, RHS, but we can try other rules also. So whenever we see two right angle triangles to be proved congruent, we can apply RHS. So keep it in mind that we're going to go with RHS rule. So by this rule, we state that because right angles are always equal, so we need to prove that hypotenuse are equal. For this triangle on the left, hypotenuse is AB. For the green triangle on the right, the hypotenuse is AC, and they are equal because it was equilateral triangle. So I will write here AB is equal to AC. AB is equal to AC, or you can write here AC is equal to AB, because why I'm taking AC first, AC is equal to AB because AC belongs to triangle ADC and AB belongs to triangle ADB. They are equal. Reason we'll give reason also because triangle ABC is an equilateral triangle. Now we need one more side. You can see clearly that AD is in triangle ADC also. This AD side, green one, is a part of triangle ADC. At the same time, AD is a part of red triangle ABD also, or ADB also. So right here, this side AD is equal to AD because AD is in ADC also, in triangle ADB also. We got reason here because it's common. It's a common side. So this is a common side. It's a part of both of triangles on the right and on the left also. So 2 reasons enough. We proved hypotenuse equal. We proved one of the side equal, and it is right angle triangles. So triangles are congruent. So hence triangle ADC and triangle ADB, these are congruent by RHS rule. Now when two triangles are congruent, their corresponding parts are equal. We call this as CPCT. CPCT stands for corresponding parts of congruent triangles. So parts can be sides also, parts can be angles also, because we proved that two triangles congruent. So their three sides should be correspondingly equal to three sides of other triangle, and three angles also equal to corresponding three angles of other triangle. Now we have to prove that BD is half of AB. BD is half of AB means we just need to prove that D is a midpoint. D is a mid value or the midpoint, which we are not given. Midpoint means if I can prove that BD and DC, they are of equal length, it's done. D is a midpoint. Now, are they of equal length or not? We need to say that because these two triangles are congruent. You see here, these two triangles are congruent. Hypotenuse is equal to hypotenuse, and this side is common. So, because they are congruent by CPCT, corresponding parts of congruent triangles are equal, their third sides must be equal. And the third side is only BD and DC. So, we write here BD is equal to DC. That's the reason corresponding parts of congruent triangles. That it means D is a midpoint. D is a midpoint of side BC. If D is the midpoint of BC, that means BD or DC is half of AB. Therefore, BD is half in length of BC. It's done. So if you have sound grip on the concept, if you have good conceptual knowledge, in this case 4 rules on congruency, SSS, SAS, ASA, and RHS, then any questions of congruency you can do in quick way, and I try to explain you exam question, the basic writing skill. So that's the writing skill. If you follow the proper writing skill, proper writing way, you can get very good marks in IGCSE exam. I hope you guys understand.